Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In this video, I want us to look at limiting reagents. Previously, we have looked at the introduction of what are moles and all of that, right? We introduced what are moles, all the formulas related to moles. And then on the second part, we did stoichiometric calculations. Now, when we dealt with more depth of the topic, and then now we're going to continue with it. Okay, when you understand stoichiometric calculations, then everything from now on is going to be smooth. If you understand this part, these three steps, you're going to use them all everywhere. Okay, so even as moving to what we refer to as limiting reagent, you're going to still need those three steps used in stoichiometric calculations. So we first need to define what is a limiting reagent. So we say a limiting reagent, it is a substance, right, or a reactant. That is what that is completely very important, completely used in a chemical reaction. Very important. Very important. A what? A substance or a reactant, more specifically a reactant, okay, that is completely used. Very important. Completely used in a what? In a chemical reaction. Okay? So the keywords that this reactant, a limiting reagent can be they can say limiting reactant or reagent, it's the same thing. So it is a reactant that is completely used in a chemical reaction. So it means now our limiting reagent will find it on the reactants. Okay? Another thing that you should take note of, a limiting reagent, this is its definition. This is the definition. Okay? What does it do? It a limiting reagent determines the amount of products formed. Okay, it also, a limiting reagent also does what? A limiting reagent also determines the excess abo x abo x. How is excess written, Maravel? Let me quickly confirm. Yeah, excess like this. The excess of the other reactant. These are the two things that the limiting reagent does. So it firstly determines the amount of products that are formed and also tells us the amount, okay? The amount that is in excess of the other reactant, okay? So it means if I'm having a reactant between, let's say we have, let's have an example. Let's say, okay, steps on how to calculate a limiting reagent, okay? Steps. First one, what you need to do on the steps, on the first step, you do convert both reactants, number of moles, okay? The second step, compare using mole ratio. Which one is a limiting reagent? okay, or the one that is in excess. Okay, I repeat, if A reacts with B, whatever that it forms, it's fine. If A, it is a limiting reagent, then it means A, it is in excess. Okay, remember what is a limiting reagent? It is a product, sorry, it is a reactant that is completely used in a reaction. So if A reacts with B, what will happen? If A is finished, then there will be some of B that is remaining. Again, there will be some of B that will be remaining. Therefore, we call that the one that is in excess. Okay. How do I do this? Let me make an example so that this becomes easier for us to digest. Okay. If I'm having the ratio between Mpo and Lebu again, okay. If the ratio between the two it is 1:2, I know that if Mpo has 2 rand, Lebu should have how much? 4 rand, according to the ratio, right? So if this is the case, it means no one is a limiting reagent, okay? No one is limiting the other, okay? But now, what if okay, let me say if Mpo has 2 rand, Lebu is supposed to have 4 rand. These are the initial that they need to have, okay? Initial that they need to have for everything to be okay. Okay. What if now it happens that, okay, if these are the initial, it means when they react, these two, when we go to the store, Mpo is going to use his 2 rand and Lebu is going to use his 2 rand again, sorry, his 4 rand, because the ratio is 1:2. Okay. Or let's say we are mixing money, but this money we should mix it in a ratio of 1:2 for us to get whatever that we want. But what if now Mpo has 2 rand, but instead today Lebu has 3 rand? So can you see that according to the ratio, this is what they initially have, okay? What they have available. This is what is available, okay? But what is it that is required? What is it that is required? I know that if Mpo has 2 rand, it means Lebu is supposed to have how much? 4 rand. So can you see that Lebu does not have enough? Okay, can you see that Lebu does not have enough for that day? So it means Lebu is a what? Is a limiting reagent. Why? Because when you go to the store, it means Lebu is going to use this 3 rand, all of it. Okay, because this is what is available. But now, is Mpo going to use this 2 rand, all of it? No. Why? Because for Mpo to use this 2 rand, Lebu needs to have how much? 4 rand. So it means now, with Lebu having 3 rand, it will cost Mpo to use how much? The ratio, remember, it is 2:1. So it will cost Mpo to use how much? 1 rand, 1 rand 50. Okay. So if Mpo uses 1 rand 50 now, can you see now that there is something that Mpo is going to be left with? Okay. So it means Mpo is going to be in excess. Why is Mpo in excess? Because there is some money that is left. So it's going to be in excess of how much? Of 50 cents. Okay. Yes. Let's try to do this in a more practical manner so that we understand. Okay. Let's say we have what's this? Okay. Let's have an example. Um, Methane. Okay. Methane. It is CH4. React. Okay. Okay. Let me say 5 grams of methane. What is methane? Methane, it is CH4. React with, um, let me say, 12, 12 what? 12 grams of oxygen. I get in a combustion reaction. Okay. Then the question is, which one of the two reactants is a limiting reagent? Very beautiful question. Okay, when we answer this, remember the first step says now we calculate what? We convert both reactants to number of moles. Okay, so it means now on the first step, which is what I'm going to do now, I'm going to first, let me write it here, step one. I'm going to convert methane to what? To number of moles, okay? Because can you see I'm giving grams of methane. So remember, if I'm giving the grams of methane, I mean the mass of methane, I need to calculate its molar mass, okay? So that it becomes N is equal to M divided by molar mass. What is number of moles is what I'm looking for. What is mass of methane? 5. Then when you use your molar mass for methane, it's going to be 12 plus 4 into 1, which is 16, okay? Then it gives me something like, something like, let me quickly use my calculator. Where is my calculator? Okay, let me fetch it first. So we have 5 divided by 16. 5 divided by 16. It gives me something like 0.3125. Oh, okay. Let's assume that the balanced equation for this reaction it is CH4 plus O2 is going to produce CO2 plus H2O. Is it balanced? No. Let me take it here and try to balance it. Okay, H2O needs to be 4 H2O. And then I'm having, no. Just 2 H2O. And then if that's the case, I'm having oxygen 2, 4 here. Then yeah, it's balanced. Okay. Now, let's calculate the number of moles. Okay, I need to indicate that this is the number of moles of what? Of methane. Remember, you need to indicate number of moles of methane. Okay, these are the ones that are available. Okay, these are the ones that are available. Okay, then what is it that I'm going to use again? I'm going to say, okay, let me find number of moles of what? Of oxygen. What is the mass of oxygen? It is 12 divided by what is a molar mass of O2? It is 16 times 2, which is 32. Then I have something like number of moles of O2. It is equal to what? 12 divided by 32, which is 0.375 what? Moles. Okay, please indicate what? Moles. Okay. One thing that you need to do for you to compare between the two, which one is the limiting reagent, which one is in excess, what you need to do is, okay, I'm gonna take this down here. Okay. Okay. So that we have enough space. What you need to do, you need to say, okay, you have found these are the ones that are available. Okay. This is the one that is available. Okay. So I'm gonna say let's use the ratio between what? Methane as well as what? As oxygen. So the ratio between methane and oxygen, it is, can you see here? It is 1:2. So it is 1:2. 1:2. 1:2. And then what you need to do is assume that you only know this one. Okay? Assume that you only know this one. What do I mean by that? You need to compare if I have 0.3125 of a methane, how much do I need? How much do I need of oxygen? Okay. Then can you see that what you need of oxygen? Let's say let's put X here, and then do cross multiply. This multiplied by that is going to be X. It is equal to this multiplied by that is going to be what? 0.625 moles. Okay. So this is what. Remember, X is the same as number of moles of O2 that is what? That is required or that is needed thereof. Okay? X, it is equal to number of moles of oxygen. That is what? That is required. Okay, let me use a simple English. That is needed. Okay? That is needed to do what? To actually react with what? With CH4. But let's check. If this much of O2 is needed, if this much of O2 is needed, how much does O2 have initially? Can you see now that O2 initially has 0.375? So it means now that O2 has less than what is required of it. So it means now, it means, can you see that the number of moles of O2 that is available is less than, okay, the number of moles of O2 that is needed. So if that's the case, it means therefore O2 is a what? Is a limiting reactant or reagent. Why is it a limiting reagent? Because if a CH4 comes with 0.3125, it means how much do we expect of X? Okay, we assume that we do not know how much X has, so we want to see how much we need of X. Then in actual fact, we get that we need 0.625 moles of X. But is X having that? No, X has less than what it has. So it means now it is a limiting reagent. Or someone might say, let's do this. I want you to see this. It also works in both ways. Even if you were to do assume that you know only, what is this? Okay, let me shift it here. Cool. Now let's assume that we do not know what's this? CH4. So you're still gonna say CH4 is to O2. The ratio is still the same, 1 is to 2. Let's assume that we do not know how much we need of X and then use O2. O2 it is how much initially? 0.375. Okay. Now when you do our mathematics, it's gonna be 2x. Okay. This is gonna be 2 multiplied by x. It's gonna be 2x. It is equal to 0.375. Then when you solve for x, which is the same as number of moles of what? In this case, of CH4. That is what needed. It is equal to how much? When you say 0.375 divided by 2, you get something like, I do not have enough space here. You get something like 0.1875 moles. Okay, let's see. If we need this much of CH4, okay, let me use a different highlight. If we need this much of CH4, is CH4 having enough of that? Let's check. Can you see now that CH4, what is available for CH4, it is 0.3125 and it is greater than what is needed. So it means now, since number of moles of CH4 that is available is greater than number of moles of CH4 that is needed. So it means now, therefore, CH4 is in excess. Why is it in excess? Because not all of it will react. Because if I'm having 5 rand and they want only 3 rand from me, can you see that not all of my 5 rand will react? So it means now I'm having more than what they need. So it means I'm gonna have something left. But now, in a case of O2, if I have 3 rand and they require me 8 rand, can you see now that I do not have enough? So it means now I'm gonna limit people. I get. So if CH4 is in excess, therefore, what O2 is a limiting reagent. Remember, that's what I said. If the other one is in excess, it means the other one it is a limiting reagent. Okay, between the two things. Okay, now let's look at the actual question thereof. Gonna consume my space here. Okay, in here they say a 8 no, let me ignore this a 8,4 grams sample of nitrogen okay, reacts with 15 grams of hydrogen, okay, then the balanced equation is as follows there, that. So determine number A, which reactant is a limiting reactant, okay, which reactant is a limiting reactant or reagent, okay. How do we do that? Remember the first step, okay. Oh, remember this was step one. Step two, it is to compare. Step two, it is to compare. Now let's look at these. Let's look at number A. For number A, remember I need to convert number of moles of both my reactants, which is nitrogen in this case, as well as hydrogen. So I'm going to say number of moles of hydrogen, it is equal to mass divided by molar mass. How do I know? Because I'm giving the mass. Again, how much is the mass? The mass of okay, let me take this question to its page actually. Okay, remember we just said for number A we need number of moles of both my reactants. So I'm gonna need number of moles of H2, which is gonna be mass divided by molar mass. Some people do molar mass like this. If your school teaches you like this, it's still fine. Relative molecular mass is still the same thing. Okay. Then now, what is the mass of hydrogen? Mass of hydrogen, it is 8 divided, or sorry, not hydrogen in this case, it is nitrogen. Rather, N2. Okay. Then what is the molar mass of N2? Molar mass of N2 is going to be 2 multiplied by what is N? N, it is 14. So it's going to be 28. 28. Then when I punch my calculator, 8 divided by 28, like that, it gives me something like 0.33. Okay, I get something like 0.33. Okay, and then what you need to do, it is to use what? What's this? Get the number of moles of your other reactant, which is what in this case, which is hydrogen. Okay, so you're gonna say number of moles of hydrogen. Okay, please indicate this is moles. Okay, now, sorry, number of moles of hydrogen is gonna be mass also divided by molar mass. Then what is mass of hydrogen? What is mass of hydrogen? 1.5 divide by, you need to divide by 2. Molar mass of H2, it is 2 multiplied by 1. Okay, then I get something like 0.75 what? Moles. And then I'm complete with step 1. This is step 1 again. This is step 1. Step 1. Let's do now step 2. Step 2 says I need to compare using the ratio. Again, how do I compare using the ratio? I say the ratio between N2 and H2. Okay, then what is my N2? My N2, the ratio for N2, it is 1:3. So it is 1:3. So let's assume that I have of this one 0.33. Let's assume that I know of N2. Let me shift it here so that I will do the other option. This is the last time that I do all the 2 options. So from now on, you'll choose the one, either of those 2, okay? Then let's assume that we do. Remember, these are the initial, okay, or the one that is available. So we need to know, okay, if 0.33 of N2 is available, how much of H2 is needed, okay? So when I solve my mathematics thereof, it's going to be x multiplied by 1, which gives me x. It is equal to what? 0. Okay, x is going to be 0.33 multiplied by 3. So remember, x, it is what? Number of moles of H2. That is what? That is needed. So it's going to be something like 0.99 moles. Can you see? But in actual fact, if this amount of N2, of H2 is needed, how much does H2 have available? H2 has 0.75 that is available. Do you agree? So it means now the number of moles of H2 that is available is less than the number of moles of H2 that is needed. So it means let's say maybe H2 available it is 3 rand and they want what 5 rand. So can you see that the one that we have it is less than the one that they want. So it becomes a what? A limiting reagent. Okay, therefore H2 is a limiting reactant or reagent. Even if you say reagent, it's fine, still correct. Let's use the second step and see. Okay, let's use the second step and see if we still get the same conclusion. Nah, not the same answer, the same conclusion. Okay, let's use N2 again as well as H2. The ratio is still 1 is to 3. Let's assume that we do not know N2 in this case. Okay, let me use a different letter. Y. Okay, then what is H2? We know H2 availability is 0.75. We assume that you do not know N2. We want to know if the available is going to be enough for the one that is needed. So it's going to be this multiplied by that 3y, it is equal to this multiplied by that 0.75. And then when you solve for y, you get that y, which is equal to number of moles of N2 that are needed. Okay, it is equal to how much? 0.75 divided by 3. I get something like 0.25 watt moles. But now, in actual fact, we see that if this much is required of N2, is needed of N2, is N2 having enough? Yes, N2 has 0.33, which is enough. So it's the same as like maybe having 3 rand and they want what? 250 from you. 250 cents from you, so you have enough, right? So it means now what? It means therefore, so we can see that the number of moles of H2 that is available is greater than number of moles of H2, of N2, sorry, this is N2. N2, you're talking about N2 here. N2, that is needed. So if that's the case, therefore, N2 is in excess. Okay, if N2 it is in excess, therefore it causes the other one to be what? A limiting reagent. Therefore H2 is a limiting reactant. Okay, do not stop after saying N2 is in excess, because the question was which one is a limiting reagent. So you need to conclude therefore. But if you have done this, then it automatically gives you the answer. Okay, so either way we use, it's going to be fine. From now on, I'm going to use just one of those two. Okay, just one of those or one of those two. Okay, then I'm gonna move on. This is the last one for limiting reagent before we move on to uh percentage purity as well as percentage composition on the next video. Okay, then that's it for what is this topic? Quantitative aspect of physical and chemical, also of chemical change rather only. Okay. Oh no. I need to talk about percentage purity as well as percentage what. Okay, yeah, but I'll talk about it. It's fine. Let's look here. A fertilizer, ammonium sulfate, you are giving it here, is produced from the reaction of what? Sulfuric acid as well as ammonia. Okay, according to this balanced reaction here. Can you see there was an error of typing there? Then I'm told that 2 kilograms of sulfuric acid, okay, 2 kilograms of sulfuric acid and 58.82 moles of ammonia are available. Can you see? Available to produce the fertilizer. 7.1, define what is a limiting reagent. Remember, a limiting reagent, it is a what? A substance that is completely used in a substance, preferably we'd say a reactant, okay, that is completely used in a chemical reaction. You should know all your definition as per exam guideline. I'm going to erase it. 7.2, it is the interesting stuff that I'm interested in. Okay, this is what I'm interested in. Oh, I just realized that we did not complete number B. Okay, before we move on to this one, let's complete number B. Let's complete number B. Okay, I'm just realizing now. It's no big deal. Now, you now know how to calculate the limiting reagent, right? So to calculate the mass of ammonia for number B, the mass of ammonia that it can be produced, you need to use a limiting reagent. So to the steps that you already know to calculate a limiting reagent, now you need to use stoichiometry. Now, okay? But the first step, instead of calculating the number of moles of the unknown, is what? You first calculate the number of moles of the limiting reactant. Again, then the second step, you use mole ratio between what? Between the limiting reactant as well as the one that is unknown. The one that they're asking you. Okay. Then number 3, calculate unknown. Can you see, we did not necessarily change the equation or rather the normal stoichiometry, but instead of calculating the one that we know, it is the one that we know we need to find it is the what? A limiting reagent first. And then use the mole ratio between the limiting reagent or reactant as well as the one that they want and then calculate the unknown. Okay. Then it means I can answer number B now. Step 1. Let's calculate the limiting reagent. I check. Step 1 complete. Yes. Why? Because I already know which one is the limiting reagent. So I have calculated the limiting reagent. Okay. So if H2 is a limiting reagent, it means I'm going to use its number of moles that is available because these ones are the ones that are going to be completely used. Okay. So this one is the one that is of limiting reagent. Okay. This one is just to help us fail. Okay. So when you want to calculate number of moles, okay, after seeing which one is the limiting reagent, we're going to use the number of moles of that one. Which one are those? The number of moles of the limiting reagent, it is which one? 0.33. So we already have number of moles. And you do not say number of moles of limiting reagent. You just tell us what is number of moles of limiting reagent. Number of moles of what is our limiting reagent? It is H2 in this case. If let me just confirm, H2 is the limiting reagent. So number of moles of H2, it is 0.33 moles. Okay. Then this is step 1, complete. Then let's move on to step 2. Step 2 says what? Use the mole ratio between the limiting reagent and then the unknown. Which one is the unknown? H2. The unknown is the one that they asked us. They asked us with regards to, which is what? Ammonia. Ammonia, it is NH3. So it's going to be between H2 as well as NH3. What is the ratio between this one? It is 1:2, if I'm not mistaken. Okay, yes. Then here we do not compare. We just want. We now know that H2 has this one available, which is going to fully react. Then X. Okay. Then this is just the normal stoichiometry that we did. Then X, which is equal to the number of moles of NH3. Okay, it's gonna be X multiplied by this, which is X. Then 0. This one. So it's gonna be just 0.66 what moles. Okay. Okay. Then I can now calculate what I can now calculate what is required of me. What is it that is required? Step 2, complete. Again, step 2. Step 1, okay, complete. Step 2, complete. Then step 3, calculate the unknown. What is the unknown? The mass of ammonia. So remember, when they want the mass of something, I should automatically come to conclusion on finding what its molar mass. Again, so remember number of moles. I have number of moles, which is 0.66. Then my mass, it is the mass that of ammonia that I'm looking for. Then what is molar mass of ammonia? Molar mass of ammonia, I'm no longer collecting the data because you now used to this again. So ammonia, it is 14 plus 3 into 1. Okay, then it is 17. Then the mass of NH3, it is how much? 0.66 times 17. Quickly, 0.66 times 17. It gives me something like 11.22 grams. Can you see? Beautiful, right? Let's look at this question. We're still going to apply the same thing. First step, it is to calculate, use the steps of limiting reagent, and then the minute they say define limiting reagent, or the one is in excess or what, you just know you need to find the limiting reagent first, again, and then use a stoichiometric calculation there. Okay. 7.1, we now know what is the limiting reagent. We have already defined that, right? So we were already in a position of calculating this. Remember, we have what? 2 kg of sulfuric acid as well as 58.82 of ammonia. So remember, what are the first step? The first step, it is to calculate the first step of determining a limiting reagent. We need to determine a limiting reagent. So the first step of determining a limiting reagent, remember, are those two. You first convert them to number of moles, both of them, and then compare. Okay. So in this case, I can say number of moles of H2SO4, it is equal to mass divided by molar mass. Okay, this is my mass. Then what is my mass? Remember, mass or mass. However, in chemistry, we always convert my mass to grams. So my mass of, let me just do it here, mass of H2SO4 is equal to 2 kilograms. So remember, if you do not know how to convert, every time when you have a kilo, just remember a kilo is times 10 to the power of 3. So it means this is the same as 2 kilo, replace it with times 10 to the power of 3 grams. Okay, this is the same as multiplying by what? By 1,000. Okay, you multiply that by 1,000, then you get how much? 2,000 grams. Okay, this is in actual fact what? 2,000 grams. So mass 2,000 grams divided, what is molar mass of H2SO4? Molar mass of H2SO4 is going to be 2 multiplied by 1 plus what is sulfur? Sulfur, it is 32 plus 4 into 16. Then I get something like 64 plus 32 plus 2, something like 98. For molar mass of H2SO4. You should be in a position of knowing that. Okay. Then how much do I get? 2,000 divided by 98. I get something very, very beautiful, such as 20,408. Or let me just say 20,41 moles. I do not like converting before final answer, but it's fine. Okay, it's fine. But let's calculate, let's see number of moles of ammonia. In this case, we can see that we are already given the number of moles of what? Of ammonia. So we're just going to put them here so that we remind ourselves. It is going to be equal to what? 58.82 moles, right? Then I already know the available. This is the available, okay? Now I need to use my mole ratio. This is step 1 complete. Let's do my step 2. I check which one is the limiting reagent between what? H2SO4 as well as what? As NH3. What is H2SO4? The mole ratio of H2SO4, it is 1 here. Can you see? 1 is 2. NH3, 2. Can you see that? It is 2 here. So it is 2. So I'm going to use a H2SO4, which is 20,41, and now want to see how much of NH3 that I need. Okay, so I'm going to say X, which is equal to number of moles of NH3 that I needed, is going to be equal to X multiplied by 1, it is X, then 20 multiplied by 20,41 multiplied by 2, it is 40,82 moles. Then I check, is what of NH3 needed? Okay, does NH3 have enough to cover what is needed? Let's check. In actual fact, yes. because NH3 has 58.82 initially or available. So it means now this one has maybe 5 rand and they want how much from it? 4 rand. So can you see it has enough and even excess of it. Okay, so we're gonna say in actual fact, number of moles of NH3 needed or available, okay, is greater than number of moles of NH3 that is needed. So it means now what? Therefore, NH3 is a what? A limiting. NH3 is in excess because it is greater. It has enough. NH3 is in excess. Therefore, or you can say, therefore, H2SO4 is a limiting reactant. Okay, can you see now? It is 7 marks and you are still cruising nicely because you understand this. Okay, now remember, I'm done with determining the limiting reagent, step 1, step 2. Where do I go? Stoichiometric calculation. Because now the question is calculate the maximum mass of ammonium sulfate that can be produced. Okay, so remember I told you that a limiting reagent determines how much of product needs to be formed. Remember when I told you a limiting reagent determines the amount of product formed. Okay, yes. So let's actually do that. Use now what? Stoichiometry. Use now what? Stoichiometry. Stoichiometry. Okay, how do I use stoichiometry? I'm gonna say step 1. Remember, I'm still continuing with this question. Step 1, what does step 1 say to me? Step 1 says you calculate the number of moles again. Okay, this is step 1 of stoichiometry. It is complete. Again, step 1 of stoichiometry, it is complete. Now finding what? Number of moles of a limiting reagent. What is a limiting reagent? H2SO4. H2SO4. Okay. H2SO4, which is what? Remember, we look at the initial, the available one for H2SO4. This is what we refer to as a what? A limiting reactant. Therefore, it is 20,41. We already know that. 20,41 what? Moles. And then I go to step number 2 of my stoichiometric calculations. Remember, it says what? Use the mole ratio. Use the mole ratio between what? Your limiting reagent as well as the one that is unknown. Which one is unknown in this case? They want what from the question? Ammonium sulfate. So I'm going to use my mole ratio between what? I'm going to use, let's do step 2 here. I'm going to use the mole ratio between my limiting reagent, which is S2SO4, as well as ammonium sulfate. I'm not sure if I wrote that very well. I don't think so. I think ammonium. Let me quickly confirm that. NH4SO4. Okay. NH4, ammonium SO4. Then the ratio between H2SO4 as well as ammonium, this one, can you see it is 1 is to what? Is to 1. So it means now, if that's the case, if the ratio of Y is 1 is to 1, it means now whatever number of moles of H2SO4 is equal to what? Number of moles of what? Of NH4 to SO4, which is equal to how much? 20,41 moles. You can do the X and what, but you'll see that it gives us this. Okay. And then how much do we get? Then, okay, step 2 it is complete. Then I'm going to do step 3. Step 3, they want what? The maximum mass. Okay, do not be intimidated by the weight maximum is still the same. The number of moles is equal to mass divided by molar mass, like that. What is number of moles? Number of moles, it is 20,41. It is equal to what is the mass? Mass is what I'm looking for. What is the molar mass of the whole msholo? This one. So I'm gonna say what is molar mass of what? Of NH4 to SO4. Okay, let's look at that. I want you to look at this one first. Okay, so when you look at that one first, it's going to be 2 into NH4, and it is 14 plus 4 into 1. Okay, plus I look at sulfite is 32 plus what is oxygen, 4 into 16. Then I get something like 64 plus 32 plus 2 into 18. Then I get something like 132. 132. Then the maximum mass of ammonium sulfate, in actual fact, it is multiplied by 20.41. It is something like 2,694.12 grams. If they wanted you to convert in kilograms, okay, you were going to divide by 1,000. In kilograms, you're going to divide your answer by 1,000. Then you get something like 2,69 kilograms. Okay, remember from there are 1,000 grams in 1 kilogram. Okay, so if you can use this, that there are 1,000 grams in 1 kilogram, and then we have 2,694.12 grams. We want to see what is X. Then you'll do your mathematics thereof, and you'll see that X, it is 2,69412, but I've rounded off to the decimal. But let's leave that in kilograms. In case they want it let's leave it in grams. If they want it in kilograms, we just divide by 1,000. Okay, so yeah, I want to believe that you are fine by now. So on the next video, we're going to be looking at percentage, purity, and percentage yield. You're going to be looking at these two. Okay, exactly. So thank you very much, folks, for joining me in this video. Hopefully you enjoyed and are willing to know what exactly you're talking about when you talk about percentage purity, as well as what percentage yield. So thank you.